Hey guys, and welcome to Talk Nerdy. It's Monday, March 20th, and I'm your host, Cara Santa Maria. This week, we will be chatting with a PhD candidate from Caltech who is focused on atmospheric chemistry. His name is Kelvin Bates, and we'll be with him in just a moment. But before we jump in, I want to thank those of you who made Talk Nerdy possible this week. Now, remember, Talk Nerdy is and will always be 100% free to download. I want to ensure that that is always the model for the show. And in order to do that, I really do rely heavily on support from listeners like you. There's two ways that you can support the show financially. You can visit carasantamaria.com and click on the PayPal portal to make a one-time contribution, or you can go to patreon.com/talknerdy and pledge your support on an episodic basis. Those of you who did that this week include on the PayPal portal Ulrich Hanel from uh, Germany. Can't pronounce the city you're from, but thank you so much for your contribution. And also Rob Schreck from Chicago. Thank you guys so much. And those of you who pledged the top level support through Patreon include Phil T-Bear, Timothy Glover, Mark Hepburn, Pedro M. Rosario Barbosa, Christian Jeffrey David Lacer, Jeffrey Perez, Stuart Ogg, The Honorable Husband, Charles Payette, Jafe, Gabriel Felipe Jalamiro Gonzalez, Brian Holden, and Jeffrey Sewell. Also, there are a couple other ways you can support the show, most of which you can find by visiting my website. I do have a Talk Nerdy store where I have some super cool swag like t-shirts and a couple different types of t-shirts, some hand-thrown mugs by an incredible potter named H.P. Bloomer, and some hand-tooled leather pieces. Let's see, I've got keychains and bookmarks by Foster Leathercraft. But I'm also really excited to report that the Tiny Thinker's book, Charlie and the Tortoise, is back in stock. It was written by MJ Moton, and I wrote the foreword to it. And you can order it either as an unsigned copy or a signed copy. And this whole batch will be signed both by myself with a personal inscription to your little one or to you, and by MJ himself. So double signed by the author and by me. Really exciting. So make sure you grab a copy of that before they sell out like last time. Okay, guys, without any further ado, I am really excited to dive into this week's episode featuring my new friend and a really interesting scientist. We're going to be talking all about atmospheric chemistry. So here he is, Kelvin Bates. Well, Kelvin, thank you so much for joining me today.
No problem. Happy
Yeah,
to be here.
I'm really excited that you're here.
Me too.
So we have met only probably, would you say maybe 5 times?
Probably
That sounds
about
about
that.
right. And this is your first podcast,
It
which
is.
is
It's
exciting.
very exciting.
So you
This
are,
microphone thing is so weird.
I know, and the headphones
And the
probably.
headphones.
Yeah, they don't help much either. Yeah, you get used to it. But if you want, you can just take the headphones off. That's fine too. So I know you through sort of my Caltech
Yep.
crew.
So many mutual
So
friends.
many mutual friends. A lot of them who have been on the podcast before:
Yes.
Crystal Dilworth, Tegan Wall, Dagny Fleischman.
hmm
Who am I
Casey.
leaving out? Casey
I was listening
Hanmer.
to Casey's recently and realizing that I was a part of so many of these stories, like Tegan's birthday party and like his flying and things like that.
So you've been up in a plane with Casey?
Yes.
I have not yet. I'm a little scared. I mean, I
Man.
trust Casey completely. He's probably one of the smartest people I've ever
Yes.
met, but he's also like insane. And so I'm a
Kind of
little
true, yeah.
scared to go up in a plane. Although I'm sure he's quite safe.
He is
I'm sure
quite
he's
safe.
Oh, and
Goes through the whole
Christine.
checklist, makes you
Yeah,
feel very safe.
that's good. And Christine, his fiance, has
Yes.
also been on the show, although it was a remote recording because she was in
Right, in Antarctica, right?
awesome.
It's crazy.
Awesome. So your job, or I should say your degree, which is also your job when you're a grad student,
That's
does
how grad
not
school works.
necessarily afford that you go to Antarctica. Have you been
No,
able
although
to
I
travel?
I did partly get into this because of the field work. So I do atmospheric chemistry, and we have a lot of different ways of attacking the various problems that we work on. But one of them is definitely to go out and measure the atmosphere as much as we can and see if the things that we model on the computer, the things that we test in lab experiments actually play out in the atmosphere. So yeah, I started in this whole field doing some flights around California's Central Valley, with NASA as part of just a student internship kind of thing, and that's what got me hooked on
So
measuring the atmosphere.
is there crossover there then with some of the things that our other mutual friend Holly Bender does? Because she makes the optics
Right.
for some of these
Yeah, so a lot of
instruments,
hers
right?
are looking what I study is more like interference for what she studies. As far as I know, most of what she's trying to do is measure things on the ground or even below the water, I
Mm-hmm.
think,
Okay.
um, from the air. And so you have to do a lot of subtracting out whatever in the air is interfering with the spectroscopy.
Yeah.
And that's a whole different world of problems that I know very little about. I'm mostly worried about measuring things in situ as we're flying through them. But
Does it involve spectroscopy still?
I don't do too much about the
Okay.
the optical properties of these of the gases and the particles that we're looking at. I've done a little bit, um, and I guess you can use spectroscopy to get at things that are not necessarily optical properties. That's
Mm-hmm.
kind of the mechanism by which you're trying to measure the chemistry of these particles. But I do less of that, I
So
guess.
how then, if you are basically measuring the chemicals that are in the atmosphere in
Yes,
order to make determinations about lots of things,
all
right?
sorts of things.
All sorts
Yeah.
of things. How do you measure those gases? How do you know what's in the atmosphere?
Oh, we have so many different
I know I'm
ways. Where
jumping
do I
in.
start?
So there
Yeah,
is spectroscopy,
there
which
is
is
spectroscopy.
looking at sort of, maybe we can do a quick and dirty on that.
Uh-oh.
Yeah,
Hopefully none of my past chemistry teachers listen to
I
this
know.
and
I'm like,
test me on it.
you know this better than I do. I'm just remembering based on a
Oof.
Holly Bender episode, but I always think of it as rainbows. You're looking
Yeah, you're
at
looking at the properties of light, and how different aspects of what's in the air are interacting with that light, usually across different wavelengths, because different gases and particles will interact very differently with different wavelengths of light. And
mhm.
the things that are causing this smog that we can see out the window right here are sometimes scattering visible light, sometimes absorbing it, and we have different ways of measuring those things. And all of that is the spectroscopy um, component of what we do. We do a lot of mass spectrometry, which is its own thing, and
That's
it's
different.
confusing that those are
Yes.
very similar words. People say mass spectroscopy too. I
I just
think
say
it's
mass spec so that I'm
yeah,
never
exactly.
wrong.
That's what I always do too. I think it's more correct to say mass spectrometry.
Interesting.
I don't
So
really know though.
spectroscopy, spectroscope, spectrometry,
Scope has to do
spectrometer.
with vision, I
Okay.
think.
Yeah, so the optical side of
Right.
things.
Whereas
Gotcha.
mass spectrometry is not.
But
I
you're
mean,
dealing with the data. You're not
fair.
actually
I
like
do some going out and collecting it, but
yeah,
usually we go out for, I don't know, a couple weeks at a time, and then we have boatloads of data that
gotcha.
we can play with for years, pretty much.
And what are some other like mechanisms by which you get that data? I mean, it seems to me, because I don't know what I'm talking about, the only way to measure the number of gases or the concentration of gases in the air is to look at their visible properties. But are there other ways to do it?
Yeah, so the main mass spectrometric methods we
Mm,
use are to suck in those gases and then ionize them in some way.
okay.
You can either blast them with high energy electrons, which we pull in particles to our aerosol mass spectrometer, vaporize them on a 600-degree tungsten filament, and then blast them with electrons, and they shatter into a bunch of ions. Send them through a magnetic field
Hmm.
or an electric field, and you can measure the size of those ions.
Oh, and then that tells you what the subcomponents are.
Exactly.
So
Yep.
this is similar to like when you watch a forensic show and they put a
Yes,
sample of some sort of chemical into the machine and they're
I
like,
assume
"Oh,
so.
this is like bleach." Because I don't think those are based on optical principles. I think they're
To be
based
honest, I
on
have no idea how
I
those work, but I
I
think the
think that's
simplest way of
also
doing
mass
that
spec.
exactly would
Yeah.
be just throw these in a mass spec of some sort. There's other ways
Hmm.
of doing the ionization. There's other ways of measuring what those ions are, but the basics are you turn whatever molecules.
My dog just burped.
Oh man.
He just had lunch.
Fair.
Okay. Anyway, you turn those molecules.
Yes, into ions, and
Gotcha.
then you measure the masses or mass to charge ratios technically of those ions.
And that's a physical sample. Like you just go out and literally suck up air.
Exactly. So
Eh,
we're using a lot of vacuum pumps and pulling things into the plane and then spitting them out the back.
So depending on how high you're flying, how low you're flying, what you're flying
Oh
over, you
yeah,
get
so
really different
those right,
samples.
for those kinds of things. For all of Holly's stuff, it's mostly flying over things, and your altitude matters for how much of the atmosphere you have to look through, I guess.
Mhm.
But for most of ours, we have to be flying in the thick of it. So I
Gotcha.
haven't been involved in field campaigns, as we call them, that look at biomass burning. But some of those are literally you try to go fly through plumes of smoke. Actually, that's not
Ooh.
true. I have been on one that did that, but we didn't find a fire on my flight, so we were just bumming around California.
So when you say biomass burnings, you're talking like forest fires.
Yeah,
Oh,
sorry, the
man. And you have to
technical term.
literally fly through the smoke of the forest fire
Yeah,
because otherwise
it's
you
pretty
don't get
cool.
the right chemical components.
Exactly. Yeah.
Ooh. That does
Um,
sound cool, but also really
but also
dangerous.
kind of dangerous, yeah.
Yeah.
Although we do, I mean, we work with Navy pilots who know what they're doing
Oh,
and
yeah,
get
you're not
really
flying the
excited. No,
plane.
I'm not flying the plane. God, no. No. We work with pilots who get really excited about doing whatever, like, more interesting things we tell them to do. So it's like, it's a cloudy day, but we want to look at the surface of the ocean. Try to fly as close as you can without, like, hitting
Wow.
ships. And they're like,
Yeah.
okay, cool. That's a challenge. I'll take it.
Yeah, because I don't want to die today,
Yeah,
basically.
please.
Wow. And so even just sitting here, I can think of so many potential applications of
Oh,
that kind
man.
of research.
That's
But
right.
I'm assuming for your PhD, you're focusing on something more specific.
That's how PhDs work.
Right.
You take this field of atmospheric chemistry that we can come up with all sorts of little questions about, and I look at one oxidation product of one molecule that trees emit. And
Okay.
my job is to figure out what happens to that
So
second generation product in the atmosphere.
so when we say oxidation,
Yeah.
okay, so
Oh,
so
let's dive into this.
a tree is planted in the ground, it's photosynthesizing,
Photosynthesizing.
it's living, it's also
All it's trying to do is suck up CO2 and turn it into organic matter. But
yeah,
in the process, it makes a lot of small molecules that are still volatile. They'll still, I mean, if you left a plate of this small molecule out, it would evaporate
okay.
and get into the air.
Okay.
And trees have a lot of mechanisms for keeping all that carbon because
Because they need
they
to,
want to.
yeah, like because we forget sometimes that plants don't just photosynthesize; they then
They do
respire.
all sorts of other things.
Yeah,
Yeah.
they
And they
are making
lose
food so they
a
can
lot of
then
these. Yeah,
eat it.
exactly.
Okay, so
Um,
so they're sitting there, they're photosynthesizing, they're respiring, they're
yep.
doing all these biochemical things in
And
order to stay
sometimes
alive.
they lose some of their carbon, usually
Okay.
in the form of hydrocarbons. So molecules that just have carbon and hydrogen. Isoprene is chief among them. It's got 5 carbons. It's got 2 double bonds.
So isoprene is just like a species of molecule that it's
Yeah,
going to give off. That
exactly.
happens to
That
be,
happens to be emitted a lot by trees.
and it's a
Happens to be
carbon-rich
5
molecule.
carbons.
Okay.
Yeah. They use it a lot for building blocks of other things. It's the building block of rubber.
Hmm.
You can polymerize it to make rubber.
Oh, okay.
And around the world, trees emit something like 500 teragrams of this stuff a year, which is a lot. I once tried to figure out like how I could put that into more
Yeah.
understandable terms. It's like 500 million elephants
Wow.
weight. Uh,
And
it's
so
the same as the weight of methane that gets emitted by like people and cows and all sorts of other things that emit methane.
So is it actually contributing to the greenhouse effect?
So isoprene directly, very little, and
Okay.
mostly that's because of how long it lasts in the atmosphere. So methane sits around for about a decade, and in that time is contributing a lot to the greenhouse effect. Isoprene sits around for during the day about an hour before it gets oxidized.
So when you say it gets oxidized, then it is that means it's taking on oxygen?
It's reacting in the atmosphere, usually with radicals.
Mhm.
Um, or chemicals with an unpaired electron, so they're very reactive. You can think of the atmosphere kind of as a really slow burning flame.
Okay.
So in a fire, you're taking some fuel, you're burning it, you're oxidizing it, you're exposing it to oxygen in a highly reactive environment and turning most of it into water and CO2, which is the most oxidized forms of what we can do to carbon and hydrogen, basically.
Which is why when you put a lid on a candle, it burns out.
Yeah,
Because if it doesn't
'cause
have an
it's
oxygen
not exposed to
source,
oxygen.
yeah, then it
Exactly.
can't burn.
Yep. So the atmosphere is doing this much less efficiently, or much more slowly, I guess.
Which is why there aren't just flames everywhere.
Which is why, luckily, the world is not literally on fire. Sometimes it feels like it.
Seriously. Okay, so this isoprene then oxidizes. And
Does.
as a chemical, is it a gas?
It is a gas. So
Okay.
isoprene is very volatile, and it's if you leave a bottle of it out, first of all, it smells really strongly, and that's because so much of it is evaporating, getting into your nose.
Yeah.
Second of all, it'll all be gone pretty soon. But as it gets oxidized, there's a lot of different reactions that can occur, but a lot of them just add oxygen to this molecule, basically.
And then it becomes another molecule,
It becomes a different molecule.
Okay.
Yeah. It becomes physically heavier. It becomes more reactive usually, and less volatile. So more likely when it hits a solid or liquid surface to condense onto that. So
Gotcha.
eventually you can turn isoprene into molecules that are non-volatile enough that when they see a particle in the atmosphere, they'll glom onto it and contribute to that particle mass. And that's the main thing that I study, is what chemicals can we make from isoprene, which in itself is really volatile and probably wouldn't contribute to any of this particle mass that we usually call smog. And how can we take that and turn it into, or not how can we, it's not something we want to do. How does the atmosphere take that and turn it into chemicals that are non-volatile enough to contribute to smog?
Gotcha.
Formation.
So early in its kind of life cycle, it's actually not really, I guess, functionally detrimental, because
Right.
it's just a gas that is
That's
going up
floating
into
around
the air.
there. Yeah, that'll get oxidized away pretty quickly. It's not terribly harmful to you, at least in the low levels that it's out there.
And so
But-
this same principle that you're talking about studying that contributes to smog, for example, I guess industry chemists use to make things like rubber.
Yeah. And all sorts of other things. These oxidation processes are pretty fun reactions. And if you can
Yeah.
get radical chain reactions going, they're very efficient and not always the easiest to control. But they'll do the job for
Yeah.
sure.
So it's weird to me because I think a lot of people, we think in very simple terms, and we think, but trees are good.
This is what I get all the time
I
when I try to
know.
explain my science, and people are like, "Wait, so we cut down all the trees and then it'll be
No,
then
that's
it'll be
not,
good, right?"
yeah,
No,
that's not
no,
what we
that's
want.
not the answer.
But trees in their own way are contribute, because it's a really
Yeah.
complicated ecosystem.
It is a really
right?
complicated ecosystem.
Eh.
There's a lot that I could say at this point to try to dispel this. There is, I mean, the Great Smoky Mountains are smoky in large part because of these organic compounds, isoprene among them, that trees give off.
I never thought about that.
Right.
And so if you were to climb the Great Smoky Mountains, you would be like coughing and stuff? Because there's like
Uh,
smoke in the air?
Well, smoke is not a particularly good term for it.
So
Smoke
it's more
is
like the Great Smoggy Mountains.
Yeah, exactly.
Gotcha.
And there's also other things that contribute, like clouds and actual fog. But
That's true.
But
Usually
yeah, a
if
good
you're
part
in
of
a
it is-
cloud, you can breathe pretty okay.
exactly,
But
it's
I
not
guess
terribly harmful.
because that's just water.
Mostly
So
water.
But the more garbage that's in there, the harder it is on you kind of
Yes.
medically.
Yes, true. We're only just starting to figure out kind of what these organic compounds in particles do to your lungs, but then we know that the smallest of particles can actually get absorbed into your bloodstream.
And even potentially through the blood-brain barrier
exactly,
if it's really
yes.
small.
But
But-
so that's still a pretty open question. But before we get too much further, I do at least want to say that like the Great Smoky Mountains were not nearly as smoky as when they were named, back before humans were in the area. And most of these particles would not be formed if it weren't for tiny seed particles that usually come from anthropogenic emissions.
Yes. So it's the like isoprene, for example, is glomming onto garbage that's coming out of tailpipes and coming out of
That's probably the
smokestacks.
best way to
Yeah,
put it. Exactly.
okay,
So
alright.
this is not the problem in and of itself, and the ways that we would want to fix this problem do not involve cutting down all the trees.
No, no,
Largely
no,
because that would cause way more problems than it would solve, but also because it's a lot easier, as California has demonstrated, to do things like install catalytic converters on all of
Mm.
your cars and reduce nitrogen oxide emissions. Those also contribute. Stop burning coal, particularly the most high sulfur content coal
Mm.
that produce sulfur dioxide that contributes a lot to these tiny seed particles. Um, so yeah, don't cut down all the trees.
So the issue here is that when we do these things, like these things that we think of as sort of industrial revolution type things,
Yeah.
like drive cars and run machinery and burn different sort of what do you call them? Natural resources.
Hmm.
They put actual physical things in the air.
Yes.
Like these chemicals, as small as they may be, I mean, sometimes when you see a smokestack above a factory, like you can physically see the particulate matter kind of coming up out
Yeah.
of this. It's like brown or gray,
Hmm.
but you can't see the emissions coming out of a tailpipe. They are
Usually
there.
you can't.
Yeah,
Correct.
usually you
Yeah.
can't. You're right.
uh,
Sometimes with a really old car, you can't. Less
yeah.
often
Or
in
if you
California.
concentrate them enough, like people in my field have done
Uh,
experiments where you just burn a burn fuel out of a tailpipe into a bag and do experiments with that. You can see these
Gross.
emissions if you concentrate them enough. I mean, that's what Los Angeles is. You can I can literally see these emissions right now from your window in the
Yeah,
form
just
of a nice little
hanging.
brown layer at around, I don't know, 300 feet or so.
It's true. When you look at from my office window, I have a really good view, kind of looking down into Los Feliz and over sort of towards Pasadena,
Hmm.
and it's like you look at the horizon and there's literally a layer above
Yeah.
the sky is blue. Like if you look up high enough, the sky is blue. And then there's the land and there's the green things on the land. Some green things.
Sometimes.
Some green things, but a lot of buildings and roads, but some green.
Yeah.
And then in between, like literally where the horizon hits, it's like this thick layer of like
Hmm.
it's brown.
Yep.
That's so gross. And it actually obstructs the mountains.
Yeah.
So I always say,
But
it's a
hey.
clear day in LA when you can see the snow-capped mountains, because when you can't see them, it's because there's literally smog.
But LA has done a great job of
Yeah.
cleaning up, and
It was way worse
it
before.
was way worse before. Atmospheric chemistry as a field kind of, I mean, I don't know how much claim we can actually lay to it, but Caltech likes to say that kind of started at Caltech because of how gross the air here was,
Yeah.
and it was a great place to study it because there was actually a need for it. And as people started to find out that the smog here is caused by a combination of hydrocarbons, less so isoprene just because we don't have that many trees, but more from
Mm-hmm.
like evaporating gasoline and things like that. When you combine those with other stuff like nitrogen oxides um, and sunlight, you can get smog. And so how can we reduce this? We can install catalytic converters. We can install those little things around a gas pump that like suck back the vapors while you're
Mm.
pumping gasoline.
And that actually contributes.
Yeah, that was
Oh.
huge. Turns out it's still weird when I drive to Arizona. You don't see those, and you
Oh,
can see the
interesting.
like vapors coming off,
Ugh.
and I mean, they don't have nearly the problem we do because there's not 18 million people living in a little basin that traps pollution, but it's still not good.
Yeah, no, seriously. And we talk about it like the 80s were kind of the heyday of like terrible smog and pollution in
Yeah, I
LA.
know. Even like the early 50s, they had to, or maybe it was the late 40s, they had to close schools
Ugh,
for almost a month because they didn't want kids playing outside in
that's horrible.
smog. They have
Yeah.
pictures of like you can barely see the building across the street because of the smog in downtown LA.
And the
People like to say,
population wasn't nearly as big then.
yeah, um, they had a lot of industry in the basin, a lot of which we've kind of told to get up and leave since
Hmm.
then. But also, most of it was just because the infrastructure that fed cars was
Yeah.
far less conscious of this, and the cars themselves were much dirtier.
Yeah. I mean, we were kind of the first in the country to do smog
Yeah,
testing, and now it's like required. I mean,
yeah,
I I
It's
drive
California
electric, so
for
I don't
you.
have to get a smog test,
And I
which is
drive a
awesome.
Prius.
Yeah, it's like one of the perks, right? But yeah, we California kind of set the standard for that,
Yeah.
and then most states actually followed suit
Yeah.
because there was a drastic reduction. But obviously, it's still a problem.
Yes.
Obviously, there is still a connection, even though we're not as, like you said, aware. Maybe it's not that we're not aware, but the measurements, the science is still coming in about like the difference between walking outside in Los Angeles and walking
Yeah.
outside in like Missoula, Montana. Like, how am I actually being
Yes.
affected
And that's
biologically?
right. There's a lot going on right now that I am not involved in. I don't know the details of
Mm,
entirely, but I know people are starting to look at like asthma rates with as they vary as a function of proximity to a freeway,
yeah.
and you can really see within 100 meters of a freeway, you have much higher health risks, just because of that constant exposure, even to not the horrendous smog of the, I don't know, 60s or whatever in Los Angeles, but low level constant emissions from cars are still not good for you.
Yeah. It's
I
kind of like,
mean,
well,
that's
duh,
right.
but at the
That's
same
not
time,
terribly surprising at this point, but
but at the same time, seeing the hard data is,
mhm.
I hopefully wakes people up a
Yeah.
little bit. And so what you really contribute to is analyzing that hard data. So the data is collected, you analyze that data, and what is the ultimate goal of, or would you consider the work that you do basic or applied research,
I would
first of
consider
all?
it fairly basic. I'm
Okay.
not really looking into, I mean, the the work that I publish will have some influence on what people try to target
Hmm.
as they attempt to clean up, especially places well, places where there are a lot of trees. And so doing the same things that LA did to clean up our smog isn't necessarily going to work in like Atlanta, which is surrounded by really productive trees, even if they're not like full on forests. The Southeast has so much green.
Mm,
Um, and a lot of it produces a lot of isoprene.
mm.
And we've done field work there and seen that a lot of the particle mass there can be directly traced back to isoprene. And so my work will be informing kind of what you need to, yeah, what components are in the particles and therefore what you might need to target if you want to remove some of that. But the how, I guess, is somebody else's
It's
issue.
somebody else's problem, yeah.
Yeah.
And so when you got into like now you're working in atmospheric chemistry, but when you were an undergrad, I assume there wasn't a capability to be so specialized?
Yeah, well, I also went to a liberal arts, small liberal arts school. Um, we had, I don't know, something like 10 chemists in my class, chemistry
No.
majors. So
That's hilarious.
I didn't even,
Where'd you go to school for?
Davidson, North Carolina.
Oh, nice.
Um,
You're a North Carolinian?
no, no. Well, I was for 4 years. It was a good
Gotcha.
4 years. I'm
Gotcha.
from Seattle originally, so it was a culture shock a little.
Yeah, that's an and what made you want to pick this kind of random school? Was it because you were there for other reasons, or did
Not
you
really.
really
I
like their
wanted
chemistry program?
no, didn't know that I necessarily wanted to do
Gotcha.
chemistry. Actually, the main thing that I knew I wanted was to be able to go to a school where I could major in whatever probably hard science I wanted, but
Hmm.
be able to take classes in all sorts of other things and be able to like participate in a theater program and things like that and not feel like I was totally pigeonholed into just doing chemistry. And
Which
so I was
is
like really excited by everything that was going on at Davidson, everything that I would still be able to do while I was there.
mm,
And yeah, it worked really well for that.
which is why it's probably good that you waited to go to Caltech until your PhD.
Definitely. I
And
would not have survived here as an undergrad.
yeah, and that's not because there aren't great creative outlets, but it's because it's a very specifically targeted academic school.
Yes.
It's a science and mathematics and
Yeah.
engineering school. You're not going to get a strong liberal arts,
Right.
training at Caltech. That's just not why kids go there, right? They go there because they want to be physicists and
Exactly.
chemists and
And as
engineers and
an
things of that nature.
18-year-old, I did not know that was what I wanted to do.
Absolutely, which I think is common. I think a lot of
Yeah,
people who are listening to the podcast right now who are just starting college have no idea what they want to major in.
I'm all for
Yeah, me too. I
it.
was the exact
You
same
shouldn't
way.
need to.
Yeah. All right. So, guys, we're going to take a quick break to thank the sponsor of this week's episode. But when we come back, we're going to continue talking with Kelvin Bates, and we are going to dive into some of that arts experience, kind of the hybridization of art and science, because I always love to bring that up on the show. We'll be right back in just a moment. All right, guys, let's get back to the show. So we're back with Kelvin Bates, and we've been talking about his work as a PhD candidate at Caltech in atmospheric chemistry. Talking a lot about isoprene.
Yep.
Yeah, you got
That's
to
pretty
start a
much all I do.
band. You should start a band called Isoprene. That'd be great. But now we're going to talk about kind of the other aspect of, I guess, what takes up a lot of your time. Obviously, you're a PhD candidate, which means that like you are a slave to your degree program, right?
Fair,
Yeah.
yes.
You spend a lot of time in the lab. You spend a
Oh,
lot of time
yes.
working. You're done with all your coursework now, though.
Yes.
Yeah.
I
Thank
better
goodness.
be.
And you're working on your thesis.
I am, yeah. Hopefully defending it in about 2 months. So.
Holy shit! Why are you here right now?
Well, yeah, mostly because I need frequent breaks from the computer or I will just go totally insane.
I'm
But
sure. We actually were talking about doing this a week or two ago,
yep,
and you were in the middle of not your quals. What did you call them? Your
my
props?
props. Yeah, we have all these different hoops to jump through, and it's
Mhm.
very different school to school and even program to program. I explain this to people in like biology at Caltech, and they're like,
Yeah.
"What are these? Why do you have to do this?" But
What is
um,
it?
sometime before we defend, at least 10 weeks before we defend in chemistry, we have to write and also defend 3 research proposals. 2 of them in our field and 1 of them out of our field. And they have to basically be like what the kind of proposals that you would use for a postdoc application or eventually a faculty application to say what you'd want to do in a lab that you set up.
Oh,
And I think it's
nice.
kind of a holdover from the days when pretty much everyone was expected to go from our graduate program to a faculty position, maybe with a
Mhm.
postdoc in between. But nowadays, that's certainly not the majority, I don't
Yeah,
think.
that's
I don't
true. I
even
mean,
know,
at least
actually.
most of my friends who went to Caltech are not working scientists
Yeah,
now. And
exactly.
and that's not because they couldn't find a job, it's because that's not what they wanted to do.
Right.
Yeah.
And so for a lot of us, it kind of seems like I don't know, antiquated thing that is not terribly helpful for us, but
But you've
uh,
got to admit it's good practice. As
it
much as
is
it's
good
probably
practice.
totally annoying,
It is.
takes you out of your actual research,
I
and
would say
it's
it's
like,
especially the bad timing because at this point we just want to we have a bunch of data that we really need to form into something publishable and get out the door and
yeah.
write a thesis, and all of a sudden they throw these roadblocks in your way. But it is good practice in terms of writing science into something persuasive, really. These are the
Yeah.
kinds of things you would use for a grant application, or if you're not going into academia, the kinds of things that you would need to be able to write your science into to communicate with somebody why it's important.
And also, probably in a way, proving that you really do have a strong handle on the scientific method, like because you're kind of speaking about these issues theoretically. You're
Yeah,
you're you're trying to block out a real proposal, but it's not something you necessarily will ever do. I'm
right.
sure you get so in the weeds with your own research that just showing a clean ability to like observe, formulate a hypothesis and write out all the steps to be able to actually do that research is a good skill to have. Which it's funny, it's the core of what scientists do, but in some ways you probably get kind of really far away from it the deeper you get
Yeah,
into the weeds of your own
that is
research.
definitely true.
Yeah.
And it's easy in retrospect to agree with you on that point that yeah, these proposals are a pretty good way of making sure that you have a handle on the scientific method. Um, but, when I was in the thick of writing them, it certainly didn't seem like they were useful at all.
I'm sure.
But they're over. Success.
Good.
On
I'm
to the
very happy
thesis.
for you. And somehow you managed to continue to do a lot of really great work in sort of I guess you could call it the arts community of
I guess
Caltech.
you could. What little we have at Caltech is still a lot of fun.
Well, it's funny because you're right. There is kind of a joke aspect to it whenever any of my friends who are involved in Caltech
Yep.
theater talk about. They're like, it's Caltech theater. It's like a bunch of scientists and engineers, but it's so entertaining. And there is a core group of individuals who are incredibly talented who participate in these things. I would say you and Holly Bender stand out to me.
We've been
And
going strong for a few years
you're
now.
strong. You can
4
act. You have
years?
incredible voices. You really
Oh,
have
thanks.
training in this area. How is it just something that you've always done for fun, or did you actually spend some of your life, kind of putting in professional work into it?
I never did. I vaguely considered it, but always thought
Mhm.
that, like, I enjoy science. I'm good enough at it. I think I'll keep going with it.
Mm.
But yeah, I love both theater and singing. Got started on them in high school, I guess, and really just haven't stopped. I've been in pretty much every musical I've had the opportunity through schools to do a bunch of plays, a cappella since college. Yeah,
I love
I can't get
that.
enough.
Have you ever worked with a private coach, or do you usually
No.
you're just involved kind of in the production?
Yeah, just in the production, just
But
yeah.
you always get, like, lead roles, right?
I guess at Caltech, there's not all that much. Well, I should stop ranking on Caltech's theater program.
No, it's just you don't expect there to be that many individuals who are solely focused on the arts because they're so heavily, but it's cool to see that there is such a thriving theater community, and both in front, or I should say on stage, not in front of the camera, but on stage and also behind the scenes.
Yeah.
Like the tech theater community blows
Oh,
my
yeah, there's a lot of
mind.
enthusiasm for that at Caltech, which is great because
It's
usually it's
amazing.
tough to throw that together, but
When I saw Little Shop of Horror, like, you give the
yes.
plans to build this cannibalizing plant to a bunch of, like, JPL engineers, like, they're gonna build something that is amazing
Oh,
on stage.
yes. You better believe it.
And so it's really entertaining for me as, like, a consumer of the arts who gets to go and watch you guys perform. I always enjoy myself so much, and it's fun to see all of my friends in these productions,
Oh, good.
but
Glad you enjoy it.
they're super pro. They really are. You guys, I mean, you work hard and you have it. It's not like you don't have a director. You charge money for people to come in. They buy
Yeah,
tickets and
we
stuff.
try to be legit.
Exactly. And also, I must say, when we all go to karaoke together, you and Holly, like, you're the stars of karaoke.
Well, Holly and I have just, like, our own karaoke nights every once in a while to get it out of our system.
I love that. You do. You just go, the
We
two of
do. We
you.
just go well, no, we go to the theater house at Caltech, and we just, like, sing along to things,
That's so
basically.
great. And I heard the other day that you guys went to this, like, actually you do this quite a bit. There are these shows in my
Oh,
neighborhood
yes.
that are these unofficial, what
Yes,
are they
the
called?
unofficial musical parodies on
Yes, or
pro.
like unsanctioned or
Well,
whatever.
yeah, and they're definitely unsanctioned. They're still doing Mean Girls. This is at the Rockwell Table and Stage in Los Feliz, and it's wonderful. Oh my god, it's so much fun.
Yeah, I heard all about Mean Girls and I was like, this is amazing. And so it's a lot of kind of drag performances, right?
We thought drag was gonna feature highly in all of them. It turned out it was only really central to the first one we went to, which was the
Gotcha.
Devil Wears Prada, which was also amazing. I could just go on about how wonderful all of these have been. I think we've been to 4 or 5
Oh my God, you
now.
guys have to invite me the next time you
Okay, we
go.
will. I
It's
forget
so
what's
fun.
next. Oh, the Hunger Games, I
I
think.
know, but you know what? Crystal was telling me that, and I've never seen The Hunger
Okay, well, we
Games.
have to watch the Hunger
You have
Games
to
with you
watch it first.
first,
Okay.
and
Because
then
otherwise you won't understand the parody.
yeah, definitely.
Yeah, okay. All right. I
Oh,
will
they're
watch
so
The
much
Hunger
fun.
Games, but only for you.
Thank
That's
you.
why I'll do it.
Trust me, it'll be worth it.
So this last show, though, that you did at Caltech, you had kind of a gender bending role, right?
Oh, yeah, I did. We
But it
just
wasn't
wrapped on Company.
company,
Yeah.
and it wasn't a drag role. It was
No.
kind of an interesting way to do gender bending in theater.
Yes, so we just cast a role that would usually go to a female
Hmm.
as a male. We talked for a long time about how to change gender pronouns, whether to change gender pronouns or names,
Hmm.
and eventually went mostly with leaving them as is and kind of letting the audience make what they will of that. If they want to read anything into that, that's fine. If anything, my thought is that it draws attention to the fact that we're changing a gender up,
Hmm.
so so that people think a little harder about what it means to have this relationship between two guys instead of a guy and a girl on stage. But it doesn't necessarily get in the way of your thinking about that.
Yeah.
So yeah, I don't know how many people have seen Company. It's a bit of an uh, dated.
It's a
Would I say
theater nerd
show?
show. Like,
Yeah,
people who are
it's a
theater
theater
nerds
nerd
have
show
probably
from
seen it.
like 1970-ish,
Yeah.
69 maybe. Um, but basically, this guy is uh, musing about getting married, and has all of these married friends and talks to them about marriage, and then has um, a few girlfriends over the course of the show that you get to see just little vignettes with. So I was one of the girlfriends, played it as a guy. It was a lot of fun.
And so what was your character's name?
April.
April. So you were April.
Yes.
Were you, when you were channeling April, because of course, as an actor, you are going to develop your character personally before you go and play
Yes.
that character. Were you playing April as a woman? Were you playing
No.
April as a trans man,
was
as a
playing
gay
April
man?
as a gay man,
Okay.
which is not all that hard for me, obviously. Well, not obviously to people who are just listening. As a gay man myself, not all that hard for me.
Yeah.
But yeah, we had to think about how aspects of this character would play. April is typically just supposed to be a ditzy girl,
Mhm.
and it's interesting to think about making that a ditzy guy, and then you start thinking, well, ditzy is a term that I was about to say for better or for worse, but no, for worse. To be honest, we really just associate with girls.
That's
I
true.
just
It's
associate with
sexist.
yeah,
Yeah,
it's
we think of
straight up
ditzy
sexist.
girls, but there can totally be ditzy guys.
Yeah.
Yeah.
But at the same time, you don't necessarily. Well, it's hard to play ditzy and identify with that character.
Mhm.
And you also don't want to go too overboard on like the stereotypes,
Yeah.
which can be tough, right? So
Yeah, because you could obviously go be like super flamingly like
exactly,
Queenie on stage and just like the
exactly.
most
God knows I'd enjoy that, but
terrible stereotype of a gay man possible.
exactly.
And so then the issue is just your name is you have a female name and everybody calls you girlfriend, but
Hmm.
like that happens in life, right? It's just but they're
Yeah,
also calling you
fair.
her and she,
Yeah.
which is
So
interesting.
right, we didn't dwell too much on that, and I suppose we could have. I mean, in part because we like didn't really want to change the script and
Mhm.
deal with. I don't know if anyone had complained about that. I suppose they could have, but I don't think
Yeah.
it's Caltech theater. Come on. But yeah, we also just wanted to kind of leave it as is to show how we were changing it up and draw people's attention to this fact and make them think about what it does to how you view this relationship.
Yeah.
Do you see it on the same level as you do the ones between him and his girlfriends that you've just seen seconds ago?
Yeah. And do some of these terms and phrases that you would usually use to describe a girl but not a guy or a
Mhm.
guy but not a girl, can they translate to another gender? Like
That's right.
it's a good way to self-reflect and see where you are actually way more sexist than you thought you were, you know?
Exactly.
Because there's some of that in all of us. I mean, we talk about that a lot kind of in the skeptic movement is these unconscious biases of,
Yes.
even women are often very sexist against themselves because
Oh
there's a
yeah.
lot of social kind of pressure to do so, that we all have these unconscious racial biases that we have to kind of recognize before we can rectify. And so pointing them out to people is a really interesting approach, kind of
Exactly.
making them marinate in them a little bit. And so you got to be a tool for that, but at the same time flex some of your fun kind of
Yeah.
theater and vocal
It was also a lot of
vocal
fun
muscles.
on
I'm
stage.
sure. Yeah, Crystal told me that I'm supposed to tell you that you look amazing in like a glittery skirt,
Oh,
a
thank
sequin
you.
skirt, I think, and
I
like
did try that
stilettos.
on every once in a
Yeah.
while. Yeah, we always have one pickup rehearsal in between our weekends of shows that's just basically for us to dick around and
I
do
love it.
whatever we want with the show. So I think I wore um, 4 different dresses and a bear costume over the course of it.
It like totally makes sense for April to be in a bear costume. Everybody will get it, I swear. It's just a different creative direction we're going.
Exactly. Just roll with it. See
So
what happens.
it's funny that you mention kind of that this is a fun role for you being a gay man. And I think a lot of people listening probably have this sort of stereotype in their minds that like, oh, there's tons of gay guys at liberal art schools and like lesbians at liberal art schools and trans individuals and everybody on that spectrum. But like Caltech, that's a place where straight people go to
Do
school.
we think that?
I
Oh,
think
man.
probably a lot of people have that preconceived
Interesting.
notion that somehow like the hard sciences are straighter, as if the 10%, actually, is that an under guesstimation now that kind of the of the population about
I have
10%
no idea,
is
really.
gay? Yeah, because I think now that we don't really talk about gay versus
Right, we
whatever. We
talk
talk
more
about
about
like
a
the
spectrum.
LGBTQ
Yes, and a
sort of as a whole,
broader community.
all on a spectrum. And so whatever that percentage is,
Right.
I think a lot of times there are these stereotypes that those are artistic types. Those are individuals who are artists and
Yes.
actors and whatever, and not engineers and physicists and chemists. I mean, my God,
Well,
you're a chemist.
let's dispel that right away. There's a lot of us.
Yeah.
We actually have a pretty fun community going at Caltech. But there's also, so I hadn't even really thought of that. I suppose that is a preconception that
Mm,
perhaps it would be worth um, trying to dispel.
mhm.
What I think more about at Caltech when I'm in that bubble of a community is um, how much people's identities are defined by the science that they do.
Hmm.
Um, and it feels a lot like we're supposed to be very objective um, at all times. And because of that, we're not supposed to let any other um, subjective aspects of things we might like or do or be influence our thinking.
Yeah, you're not a
Um,
person as a scientist, you're a
yours,
robot.
right? You
Like, you
have
want
to
to take
be
all that out.
right. Exactly. And so there's definitely a culture at Caltech. I don't know how much it translates to other similar environments.
Mhm.
I guess really science and engineering heavy environments. But there's this culture of kind of downplaying these other aspects of your identity that would get in the way of you being as pure a scientist as you could be.
That's so
Uh,
interesting because I think we often think of LGBTQ individuals as either self-defining or that culture often defines them as like
yes.
if you were to say everybody wears lots of hats, you know, you're a brother, you're a sister, you're a father, you're a whatever. But
Right.
when people are like naming one thing about, oh yeah, that's my gay friend so and so, or like
Exactly.
that's my black friend so and so. But what you're saying is that at Caltech it's much more, oh, that's my physicist friend.
Yes. Definitely.
Interesting.
Definitely. Um, Yeah, and there seems to be kind of a stigma against celebrating other aspects of who
Mm,
you are
that's a
too
bummer.
widely, which is a bummer. And so a lot of us have worked hard to try to make sure that people in the community don't feel like they need to suppress any of these aspects of who they are. And this is also, I mean, this also plays into the theater and arts end of things, that there is this sense that you should be spending your time doing science and not doing the arts end of things. And so we also, of course, try to make sure to dispel that myth as well.
Well,
But
it's the only way to stay sane,
yeah,
right? Is to
exactly.
have other things that you're interested in.
Exactly.
It's like healthier. And honestly, you're a better scientist for it because you're not i- we talk about, and there's like actually really good evidence to support this kind of phenomenon wherein you're in it all the time, and then as soon as you take yourself out of it and you kind of change your mind about things and your perspective, then when you dive back into your work you have more eureka moments. Like, we know that this happens.
Precisely.
Yes, like
Yes.
there's hard evidence to support this. So of course, if you're gonna change things up and go take your dance classes or go do, you know, your theater or all these different artistic, you go paint, whatever your kind of outlet
Yeah.
is, it's actually better for you as a scientist.
Yeah, and I think I don't have the hard evidence to back it up, but I think the same applies to the matter of identity that we were just
Mhm.
talking about, where bringing all of these other aspects of your identity to the table gives you different perspectives, and different perspectives are exactly what you need to be able to look at this data and see these data, whatever, and
Ah,
see
that's
different.
good. I like that. I like
I
that.
try,
I
but I
know that
don't
one. That's
usually
a
catch
hard one
it.
that always slips by. For me, it's always, um, which is the one that really gets me. No, not further and farther. It's
Oh man,
maybe it's further and farther.
I
No.
don't even know that difference.
Yeah, that one
Really?
gets me, and there's another one that kills me all the time. It's less and fewer.
Ah,
Oh
yes.
god, that one's really tough. Anyway, these data you were
These
saying, see
data.
these
What
data.
was I saying about these
It's my
data?
fault. I
Oh,
totally interrupted.
perspectives.
Yes.
Yeah, just bringing different identities to the table that allows you to have different perspectives on these data,
Uh-huh.
and be able to draw different conclusions from it, see different things in it. And I think keeping a hold of all of these other aspects of our identities rather than trying to turn us all into robot scientists is a much more
Yeah.
productive way to go.
Which kind of leads me to a question about role modeling, which I guess before we dive into that, it- when did you come out? Were you out before you started college?
um, yeah, that's a kind of complicated,
When did you know, I
complicated
should say?
process.
Maybe when
Okay.
did you kind of at least have an inkling that
Have an inkling,
yeah.
probably age 12-ish,
Okay.
kind of like fully accept it and admit it to myself, probably
Mhm.
more like 16. But
Okay.
then coming out was a vague and broadly defined process that like happened over the course of probably at least a year in high school, but then going to college and making entirely new friends and being in a totally different place.
Then you almost have to do it all over again.
Yeah,
Yeah.
exactly.
Gotcha.
And so that was kind of like going back in the closet and then a longer process of coming back out of the closet. And then coming to Caltech, it was a much more of a like, uh, at this point, I've accepted this to its fullest extent, gone way beyond like really caring what other people think about
Mhm.
it. So I made sure to um, to own it when I got here to LA. It's also a very easy place to do so.
Yeah, it's
Um,
interesting because there's that juxtaposition, right? It's LA, and it's
yes.
like, come on, we have whole like neighborhoods
Oh
that,
yeah.
we have like big neighborhood. Like, actually, I think West Hollywood might be one of the biggest kind of neighborhoods in the
It
country.
definitely is if you define it by cities, because West
That's
Hollywood is
true.
its own city. So
That's
like
true.
maybe the
Yeah.
Castro is technically, I don't know, more of a concentration, but
Okay.
because WeHo is its own city, it's
That's
like
true.
by
Yeah.
far the most same-sex couples in a single city.
And because it is its own city, the legislation that's passed
Yes.
there is obviously very LGBTQ friendly and just really liberal and progressive
Oh yeah.
as a whole. So
And
the
then can
city itself.
influence areas around it.
Yeah,
Yeah.
absolutely. That's true. Yeah, because WeHo was like one of the first kind of places where like plastic was banned, styrofoam was banned, fur was
Huh.
banned, foie gras was banned, like all these very liberal kind of things that
I didn't know that, but I'm
yeah, it's
not
pretty crazy,
surprised.
right? But beyond that, I guess my question is, okay, so you knew all through college, you were coming
Mhm.
to terms in many ways through high school. You knew you might not have been as open about it, but you knew all through college and then into graduate school. Did you find yourself identifying or even being able to point to any professors or any maybe older
Ooh,
graduate students who were out that you could say, "Oh, there is a place for me in science. Like this science is not anti-gay."
good question. I guess less so in undergrad. It
Mhm.
was a very small community that I was at.
Did you feel like outward hostility or was it just kind of
No,
not factoring
it was
into
just
it?
kind of not factoring into
Okay.
it. But then coming to Caltech, it was pretty easy to find a community here that I could really connect with. And then, yeah, see older grad students
Mhm.
um, being successful, still, you know, going to WeHo every once in a while,
Yeah.
embracing this aspect of their identities. It's a small community, and within the wider community of Caltech is where you have this kind of this sense of needing to suppress aspects of your
Gotcha.
identity. But within this very small community that we found at the Center for Diversity at Caltech, which is a wonderful little place, um, yeah, we really I think have found a pretty successful way of bringing new members into the fold, of um, showing people that they're not alone, and
Yeah,
connecting
absolutely.
people with mentorship if they need it, with role models, or even if they don't need it, just being able to show that, hey, we're grad students, we're also gay, we have a life, we have been successful, we can help you out if you need it, I
Yeah, which
guess.
is also like wildly important in a community where how can I put this? There's its own set of pressures that a Caltech graduate student experiences, and I'm not saying that they don't experience them at MIT and at
Oh yeah,
Stanford and all
I'm
these other
sure.
places, but it's a high pressure place to be, and
Yes.
there's a lot of mental health issues that kind of
Yes.
spin out of that, and so having a recognition that not only are the individuals who are going to school here in a pressure cooker because of the environment, they're also kind of grappling with individual issues because they are
Definitely.
people who are coming to terms with who they are. A lot of times that happens during these kind of formative years because there are grad students who start when they're like 20.
Yeah.
They're like baby grad students.
Yikes.
I know,
Yeah,
isn't that crazy to think about?
it is.
Like little ones there.
And it is so important to have some sort of support network in
Mhm.
place around you. Ideally, right there at Caltech, and people who've also gone through the things that you are going through. And not necessarily that they can help you out with the little minute details of your situation, but just that they understand.
Absolutely. And that's the thing. It's like there are gay people everywhere.
There are.
Like you think of a larger community as a whole is kind of the Pasadena science community and engineering community. Then it
Yes.
involves JPL, this
Yes.
big NASA entity or hybrid NASA entity. Just like the Caltech theater is actually community, right? Like you have
Right.
NASA. Holly
Yeah.
Bender doesn't go to Caltech.
Right. She's at
She's a JPL
JPL. And
scientist.
we have plenty of people who are only vaguely affiliated with Caltech or JPL, whether they're spouses or, gosh, I don't even know how some of the people who we've done theater with are even connected.
Yeah,
But
they're probably just, close to, they're Pasadena folks,
yeah,
they're in that community.
totally.
And that's the thing, like, there are plenty of scientists and engineers who are launching rockets right now who are not straight. You know what I mean? Because it has nothing to do with anything else. Like, I think we have these dumb misconceptions that, like, being gay means you have to, like, have a certain type of career or that you have to act a certain way. But, like, you don't even know. Like, your dentist
Not at
might be
all.
gay. You know what I mean? Like, they're
Exactly. They
everywhere.
walk among us.
I know, right? And
Yeah.
it's weird to think about people who grew up in small towns who
Yes.
literally are like, but I don't know any gay people. And it's
It
like, no,
is.
you probably do.
It is really hard to identify with that. But
Yeah.
yeah, but yeah, that
Did
is
you feel
true.
like North Carolina, because North Carolina is one of those weird things. Like North
It
Carolina
is.
was with the Union, right? It wasn't a southern state, but it's still kind of
I don't know.
on the other side of the Mason-Dixon, I feel like.
It is its own weird, yeah,
It's kind of in
mix of
between.
cultures.
Yeah, yeah.
Davidson was in a small town just north of Charlotte,
Mhm.
um, and Charlotte's its own strange city that seems to consist just of like banks and suburbs and very little else. But then you've got the Research Triangle over there, which is just this
Yeah.
enormous concentration of doctorates.
And super liberal. I mean, you tend to see sort of I'm going to say a correlation just to be scientific about it, but there's a high correlation between kind of like liberal values and higher education.
Yes,
So
definitely.
definitely the more kind of like Research Triangle is such a good example. It's an island of
Yeah,
blue. It's very progressive
exactly.
area. Yeah.
And Davidson, of course, attracted people from all over. So it wasn't necessarily like I was getting a snapshot of North Carolina
Mm,
life, hardly. But it did attract perhaps a more diverse set of viewpoints
which is
than I
good.
think most liberal arts schools, certainly here in California or up in New England, usually
Mm.
would, which I think was great. It was amazing to be there during the 2008 election
Oh yeah.
and see all of that and how that played out. And to actually hear different opinions that I had pretty much not been exposed to in Seattle, let's be
Yeah.
honest. Not that much um, diversity of political viewpoints there.
Yes. But probably a very good place to curate, if you are a more progressive thinker, to curate that
Those
in and of
ideas,
yourself.
yes.
As opposed to like myself, who grew up in Dallas, is the opposite. Like I
Hmm.
curated a very progressive viewpoint, sort of out of the oppression side of things,
Oh,
like because everybody around me was so conservative. But I had friends, and I went to a liberal arts university for my undergrad. And it's a heavy music school at the University of North Texas. It's in a city called Denton, which is like everybody calls it mini Austin because it's a super progressive city. Everyone's stoned all
I
the
love
time.
Austin.
Yeah, exactly. But I have friends who ended up coming to California and are now kind of traveling the world who were never out in college because they just
Hmm.
didn't feel comfortable. And I never even knew. Like we were friends, and they sort of would have beards or they just didn't date much or whatever. And now that they live in
Yeah.
LA, they're like, "Oh yeah, by the way." And I'm like, "Oh, holy shit," because it's true.
Yeah,
It's
it
not
happens.
easy for some people if they live in a place where it's just not okay.
Very true. And I mean, the the more that I see being here, um, the more I realize just how different it can be for
Mhm.
different people. Yeah, part of it is where they grew up and what they've been exposed to, but your parents, not even necessarily how your parents feel about you being gay, but like how other ways in which they've influenced your life, um, your friends, what you're trying to do with your life. There's so many things that go into this, and so many different experiences for different people that you can never you can never guess at where people are in their stage of accepting that or coming out, and there's so many
Mhm.
different ways of manifesting it. You just have to accept wherever people are and
Yeah.
try to help them get wherever they want to be.
And it's a process for everybody. But
It
I
is.
think what you're really saying is that, like, if you're living in a small town where you feel like you can't come out, you should just move to LA. I think that's what you're saying.
I
Just
mean,
come out here, guys. You're gonna love it.
I'm sure your small towns are wonderful, but gosh, I thought that I would hate LA when I first moved here. I think all of the rest of the West Coast, or at least the northern stretches of the West Coast, have this horrible stigma against LA as this just like smoggy, sprawling, um, concrete jungle where
Mhm.
you can't get anywhere because there's so much traffic and everyone just sits in their cars all the time.
And also that everyone's really vapid,
Yes.
right?
Oh,
I
definitely
thought
that.
that before I
Vain
moved
and
here.
vapid,
Yeah.
for
And trust
sure.
me, that is here. All of those things you said
All of those
exist.
things exist to an extent, but they don't define the city.
Hmm.
And there is so much here. I've been here for almost 5 years, and I still feel like I've barely explored so many parts of it. But also, various parts of it are starting to feel like home, and it's a magical place for sure.
Yeah.
Gonna be sad to leave it.
Seriously. I do a science podcast out of LA, guys. I constantly have interesting
Yeah,
scientists.
there's no shortage of interesting people
No.
here.
Yeah. It's like it doesn't have
Doesn't
to.
have to be science, although it's a pretty interesting field. I mean,
Absolutely. And there's a ton of it
and
here.
there is
It's
a ton of
not
it here.
just actors, and producers and
Though it is
directors.
amazing how often you meet people in the entertainment, various aspects of the entertainment
It's true.
industry.
And you see
Like,
celebrities like everywhere here, which is
yeah.
a weird experience when you first move. You're like, holy shit, I know that guy.
Yep.
And you're like, oh, okay. So wait, you said you're going to miss it. Are you leaving?
That is currently the plan, yes.
For a postdoc.
So I'm finishing up my thesis here in May,
Hmm.
um, graduating at graduation in June, and I just got a fellowship to go to Boston,
You just,
go,
oh, that's so
yeah,
exciting. Ooh,
go
I love
postdoc in
Boston.
Harvard for 2 years.
Oh,
So
that's amazing. Boston's great. I mean, the snow
Boston is great.
sucks, but
Right. I
Boston's
don't
great.
know at this point, having gotten used to LA, I don't know if I can survive a winter there, but we're going to try it. We're going to see how it goes.
Yeah, we'll just bundle you up. You'll be
I'm
fine.
mostly going to be doing computer work, so I could just like sit in blankets for the entirety of winter and not come out.
I
But
already know your going away present is going to be a space heater. Like that's what we're going to send
and
you
it will
away
be
with.
easily the thing I use most, I'm sure.
Oh, well, how exciting. Congratulations.
Thank
It's
you.
amazing. Well, Calvin, we have been podcasting for an hour already. Can you
Wow.
believe that? I know. The time flies. It's so
Jeez.
much fun. But before we go, I want to ask you the same two questions that I ask everybody who comes on the show.
Uh-oh. So it's going to be compared against everyone else.
No, no, no. There are definitely more popular answers and less
Uh-oh.
popular answers
Let's
just
see if I can guess what
because
they are.
you'll know immediately. All right. So when the two questions are kind of two sides of the same coin. So the first one is, what is the thing that like worries you the most when you think about the future? And that can be in whatever context is important to you. It can be your own personal future or sort of the future of the planet and mankind or whatever. So what worries you? What keeps you up at night? What's like the most disconcerting? But on the flip side of that, what about the future do you have a lot of excitement and optimism for? So what do you think the most popular answer is here?
I'm guessing on at least the negative front, but possibly both. It's going to be something to do with like climate and environment.
Oh yeah.
Okay.
And that
'Cause I
must
was
kind of
thinking-
play into what you do as
Right.
well.
It would be easy for me to say that. I feel like I could. I definitely am very worried about the climate change issue. You know, um it's like watching a car crash in slow motion, and it's very hard to think that these slow moving forces could have such a strong impact on our planet, but we really are already seeing it.
Mhm.
I don't know, probably the one that drops my stomach most is looking at graphs of sea ice volume or
Ugh.
surface area
Yeah.
that just tank in the last decade, and it is kind of terrifying how much things are changing. But I kind of don't want to use that answer now that I already
Yeah.
have.
Everybody else already
Gosh,
took
everybody
it.
already took it.
You
Good.
can have
Well,
a
so
second one.
I mean, that in the long run is what worries me a lot. And like going back for the last 5 years when that's been the main thing on my mind, I guess. But more immediately, and the thing over the last, I don't know, few months that I've been more worried about is just kind of the pervasive shift in our culture. And I guess by our, I mean the U.S., but I think there's also echoes of this elsewhere.
Mm.
Um, that seems to be undervaluing fact or evidence. Um, I don't really know how best to put this into the words, but it definitely does seem um, it's been manifested pretty well in our politics recently, but just in general, um, that the place of science and of evidence and of fact has been questioned a lot recently, and I think it's a powerful force for driving our society in reverse. And I'm
Absolutely.
worried about what could happen if enough gets behind that to actually turn certain progress that we've made over the last, I don't know, years to centuries
Mm.
in reverse. I know
Yes.
that's pretty vague, but
No, I think everybody would agree with that. I mean, it's like you mentioned that watching the kind of the detrimental climate effects that are occurring right now is like watching a car crash in slow motion. And it's insane that literally 50% of the population is watching the same car crash in slow motion and they don't see it.
yeah,
And they're like, no, those cars will be fine. They're not crashing.
exactly.
It's just
Um,
insane.
the I don't want to say that opinions are invalid, but there's definitely a place for saying like, no, this is not a thing that you have an opinion about. This is
Hmm.
a thing that we gather evidence, we see if it supports the hypotheses that we put in place, and then we do something about it. Uh, and yeah, to see that not get the credit that it deserves is disheartening, to say the
Absolutely.
least.
Yeah, to say the least. But there must be something that you look forward
Oh, things
to.
I look forward to.
Yeah,
That's
what
a
is it
good
about the
note to end
future?
on.
Yeah,
It's good we
yeah.
did these
So
in
I
the right
always feel
order.
yeah,
Okay.
exactly.
Good. Um, I could also use the environment one. I'd say
Yeah.
that I think in the past, environmental problems, though they have frequently been of a smaller scale, have been some of the things that have gotten politicians and people in general most um, gotten them to work together
Mhm.
pretty well. And we have examples that we pull out to try to support international cooperation on the um, climate change issue, like the Montreal Protocol back in the, let's see, late 80s, I believe it was, when we realized what chlorofluorocarbons
Mhm.
and other such chemicals were doing to the ozone layer. And realized how bad it could get, and countries came together, signed an agreement, banned chlorofluorocarbons. They just amended it last year, I think, to include a bunch of other really reactive, nasty gases, and we have already seen vast improvements
Yeah,
in.
there was a big news cycle, like, I wanna say it was, like, 6 months
I
ago
think it was
about
because I think
yeah,
that's
about the
about when they
ozone.
added a whole bunch
Mhm.
of new classes of
Yeah,
compounds.
and it's
Yeah,
like the ozone is healing.
it is.
Like, it's the hole
Like,
is
this is a perfect example of a way in which we saw the problem, we
yeah.
came together, and we did something about it. And you can go further back and look at the smaller scale things that kind of influenced that, like the problem of acid rain in the
Mhm.
U.S. and Canada, and what we did to try to fix that, which was a kind of like a basic emissions trading scheme almost, that you could think of doing with CO2 also. So there's opportunity here in terms of forging cooperation out of a shared problem that I think we can get to. I think we've seen signs at Paris in 2015 of getting towards, but it's going to take a lot more work. And I also think the I have a lot of hope in technology and in
Mhm.
the progress that we can make on that end, um, and that we can fight our way out of whatever holes we get into. Maybe not whatever, but I am hopeful in general about the climate issue. I think more than many of my peers.
No, absolutely. And I think that there's a lot of good evidence to support that as well. Like we have shown that as a species, we're incredibly innovative. And those of us who are willing to admit problems can band together to work on solutions to those
Exactly.
problems. The fear really comes from lacking the political will to do so. But that's cyclical, you know? It's like
It is.
we're in a certain administration right now with certain issues.
Yep.
It's not going to last forever. We have term limits. Thank God for term limits. That's
Ain't
all
that
I'll
the
say about
truth?
that.
Ain't that the
Yeah.
truth? But I
Well,
think we can still make whatever progress we can in whatever ways we can while we're waiting for that. And so here's hoping that on the science end we can do what we can to you know collect the knowledge that will feed into that. And then I know many of my friends will be working on the more engineering aspects of what we can do about it.
Yeah, absolutely. Well, Calvin, this was so much fun. Thank you so much
It
for joining
was.
me,
Thank you.
enlightening us about atmospheric chemistry. So let everybody know who's listening right now how they can say like hello via social media,
Oh
like where they can
man,
find you.
I feel like
Are you a
I
Twitter
need I
person?
need a Twitter, but I
Are you,
don't
are
have
you a
one.
Facebook
I'm basically just a
person?
Facebook
You're a
person,
Facebook
and people are
person?
welcome to reach out to me on that. I feel
All
like my
right.
name is not that hard to find,
Yeah,
right?
that's true. Oh, I never asked you. Are you like named for the temperature
Very
measurement?
indirectly. Well, the temperature measurement is named for a person, right? So
Yeah,
it's. I
but that
mean, there's
person is like long gone, right?
true. I'm
So,
named for my grandfather. My grandfather, it was his middle name,
uh-huh.
and the story goes that he was named that because his parents, I don't know if it's where they met or if it's where they like used to meet on dates or things, was in a park in, I believe, Belfast under a statue of Lord Kelvin.
Ah,
So,
yeah, so the
cute
science
story.
runs in your DNA, really.
Exactly.
Yes, that's
I was destined
you
to
were
be here.
destined to do science. That's true. I love that. Oh my gosh, that's great. I love that story. All right. Well, again, thank you so much for joining
Thanks
me.
for having me.
Of course, and everybody listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.